Speaking of automation, our next piece is actually going to deal with that. If you have worked with developing, or at least worked with closed loop manufacturing, then you know there are kind of three key elements to a closed loop manufacturing system. First of all, you got sensing. You have to measure what your process is doing. There's thinking, or analyzing the results of those measurements and how they compare to the design intent or the design nominals. And finally, there's acting. This is kind of the big part of it, providing appropriate feedback into the process to keep it centered within nominals. And our next guest will tell us why, of the three, sensing, thinking, acting, sensing is, in his opinion, the most important. Our guest, Jonathan O'Hare, is a technology expert with Hexagon Manufacturing Intelligence, and he wrote about this in his article, Get the Scoop on Closed Loop Manufacturing, How Manufacturing Intelligence Uses the Digital Thread. Jonathan, thanks for joining us.
Yes, hello, Mike and Dirk.
In your article, you say that most of us in the quality field think of sensing as only a measurement system, and the results of those measurements as their sole contribution. But you also say that there is much more to consider regarding sensing and the overall production workflow. Can you explain a little bit about what you mean?
Yes, there's a lot more that goes into implementing the sensing element than people think about when they think about the asset itself. A lot of times people will think of the measuring solution as the machine asset, as just the CMM or the sensor itself, and maybe one person sitting in a cockpit and kind of managing that. But in reality, there's an entire workflow that goes into the implementation of that sensing element to make it efficient and to make it continuous so that a repetitive manufacturing loop can remain in place. So a lot of what we contribute in this whole workflow is the planning aspect. We have software that plans before it even goes into the execution of the control loop. It plans the routine, all the instructions of how and what is being measured about the manufactured product.
Now, Jonathan, you also mentioned in your article that inspection plans can be ruined by poor design requirements, but maybe are poor because of incorrect representations of geometric dimensioning and tolerancing GD&T. A lot of people are still coming up to speed with GD&T, so can you maybe explain the criticality of GD&T when it comes to good inspection plans?
Yeah, it's very important, because if you think about it, you require, for a good process, you're required to have a good design. So everything starts with the design. So all the information that's required to implement the execution of the measurement plan is really dependent on the instructions. And the instructions come from the design of the CAD. And a lot of this is built into many more advanced CAD formats as what they call PMI, or product manufacturing information. But in some cases, it's not provided. So we also provide tools to implement this product manufacturing information directly from other sources, such as prints and other types of databases to implement this instructions for the measurement plan. So a lot of times they'll have different types of CAD models, like IGES models that maybe don't support the product manufacturing information. So a lot of the GD&T isn't even supported by the format of the CAD model. So what usually happens is that alongside this, engineers are given process sheets or two-dimensional drawings that they have to interpret. So with that comes a lot of misinterpretation, especially if there's human interpretation of the drawings and inputting it into the software. So we would like to automate this as much as possible for the future.
And if you could maybe a little bit more detail, perhaps, I mean, how inspection plans affect sensing, or maybe the type of sensing that you need to do, and then how does all of this then feed back into the process? Maybe just kind of fill out a little bit about that last little bit, the sensors, the type of sensing, and what that means in terms of control.
That's true. So the richness of the instructions has a lot to do with the quality of the information that you get and how that manages the control of your process overall. So I can give you a good example. there might be a call out, or there might be a design requirement to meet a certain diameter of a hole or a bore on a part. However, it might not be adequate just to trace the diameter of that bore. Maybe we have to look at the roundness of that bore and understand a little bit more about what's happening in the process in order to better control it, in order to predict when tools need to change, and maybe when some of the environmental changes happen around the system, so we can predict those as well, or what the influence of those might be. So in terms of the richness of information, a lot of it goes into the planning step, and a lot of it isn't there the way it's currently provided.
Now, we're going to be doing, or I should say, you're going to be doing a webinar, I'll just be standing by, on this topic next week. Can you tell us, maybe give us a little bit of a heads up on kind of the main topics and what you're going to be covering in that webinar?
Sure. So next week, what I'd like to talk about is how sensing fits into the overall control loop as a complete manufacturing process for repetitive manufacturing. I'd also like to talk about, maybe more on the theoretical side, about where I think the implementation of sensing, or the inspection plan, is in this control loop, and what those workflows mean. And what's happening is that there's more of a division of roles among these workflows, so that it actually creates greater efficiency in the implementation of these plans. So I'm going to talk about that a little bit more, how different roles can impact the workflow, and what software tools that we provide that help us do that.
Okay, and so as I mentioned, this is going to be a webinar that we're doing next week. It's called Sensing Your Way Through Closed Loop Manufacturing, coming up next Thursday, May 4th at 2 p.m. Eastern, 11 a.m. Pacific. Jonathan here will be presenting along with Hexagon's Sean Wisner, and I'll be your host. So check out Jonathan's article below the player page down there. There's also a registration link. You can click that. That'll take you out to the WebEx registration page, and you can sign up for that webinar. It is free. Keep an eye on your email. You may also get some emails in your inbox with some more details. So Jonathan, thanks for joining us.
Thank you, Derek and Mike.
All right, and we will see you Thursday.
We'll see you Thursday. Thanks, Jonathan.
See you then.
Okay, bye-bye.
Bye.